QUCC battery management system has arrived months ago, I think. Welcome to another show here on the Off-Grid Garage. I cannot remember, they have sent it really quickly. It took only 2 or 3 weeks until the new BMS was here. Well, if you don't know the story, the old BMS broke down a little bit, so to speak. These BMSs, they don't have MOSFET transistors to switch the load on and off, but they work with a big beefy relay with a contactor. And the previous one apparently had some issues with this relay. Known issues, because when I complained and said, well, the relay is not switching off when I turn off charging or when one of the cells has over voltage, it should turn off charging, right? That's the main purpose of a BMS, protecting the battery. Well, it didn't do that. And we did some testing online and, well, it turned out the relay is not working anymore and the contacts are welded together or something. I don't know. We don't know yet. And they didn't do any discussions at all. They just said, okay, we send you a new one or we can reimburse you. I said, well, then let's send me a new one and I'll test your new one. I just want to see how this one works with the relay. Because the disadvantage of BMSs with a relay is they cannot control the power going in or out separately. They can only disconnect the battery and the load or the charger. A normal BMS with MOSFET transistors can actually control the load individually. So if the battery is empty, it does not let any energy out of the battery anymore to supply your load, but it can let energy into the battery to recharge it from an external charger, from a solar charge controller. The same when the battery is totally full and overcharged. It turns off your solar charging, it turns off your grid charger, but it leaves your load connected, so the battery gets discharged. These ones cannot do that. They just disconnect the load and the charger at the same time, and that's it. Well, strangely enough, the app coming with the BMS has a charging and discharging button, so you can turn either off or on. But how does this work with one relay only? Nobody knows exactly, and we have never tested it because the relay didn't work in this one. So anyway, tonight I'm going to replace the faulty BMS with this one here. And as I said in one of my last videos, the balance leads, I don't need to replace them. This is exactly the same electronic in here as in my existing faulty BMS. So this is all one-to-one replaceable. I just need to disconnect all these balance leads, connect it to the new one, and we are done. And I also told you I want to take off these leads here and put my own ones on, because then I don't need to fiddle around with the battery terminals anymore. Otherwise I need to polish them again, you know, underneath. Houston, we've got a problem. I cannot take off the nut here. The top plate here is in between. I need to take it off. I was hoping I can avoid that, but no, this needs to come off. All right. Yeah, there it is. It's maybe easier anyway. Okay, while we are here, we can have a quick look. If you haven't seen the QUCC BMS from the inside, there's your microcontroller, which takes care of everything, a buzzer. This is our shunt, which measures the amps going in and out of the battery. And we've got our balance resistors here, these little black things here. And we've got another 10 ohms, 10 watts resistor here. This is for pre-charging the inverter. So if the relay turns off, the inverter is without power. And if we would turn on the relay again, we will have surge current going through the contacts here, and it could potentially destroy your BMS, your electronics, and even the inverter. And this one is a pre-charge resistor, which lets through a little current to charge the capacitors inside the inverter. And then we've got the Bluetooth module here with the antenna and a voltage sense cable here, which sits on the output of the contactor. And that's pretty much it. Yeah, it comes with a temperature sensor, and there's also an SW contact, SW, which is the weak switch. And I've asked them, what is the weak switch? And they said, I need to close the contact of the weak switch to make it all work. And I said, well, in the old BMS, I've never touched this cable at all. Maybe that's why the contactor doesn't work. Can you imagine? Yeah, I don't know. They explained it to me. I didn't understand what they actually mean with that. So I leave it as it is, and we will see if the contactor works this time here, and we can get everything to work. And we also have another contact here. I think this is the RS485 communication port. So apparently the BMS can talk to other devices via this port, but I have no idea how this all works together. I read that RS485 is a industry standard for communication. So, but even in the RS485 standard, there could be differences. There could be different languages, different dialects, and it's not guaranteed that one device talks RS485 and the other one does the same, and they can understand each other. So I'm not sure how this all works. Maybe someone can figure it out and send me an email with simple instructions how this works, and I'll get it done and make a video about it. But for now, we leave it as it is. Yeah, and see these little cuts they put in the shunt here? This is for calibrating the shunt. So what they actually do is they reduce the diameter of the shunt here, of the resistor, by cutting into it, so they can increase the resistance of the shunt very slightly by making small cuts into it. Yeah, that's how you calibrate a shunt. Well, talking about the shunt, I have to disconnect the shunt because we have to disconnect the battery to replace the BMS. So I'm not sure if it will keep. I'm not sure if it keeps the history. So I just want to show you something which I found incredible here on the smart shunt. If we go into the history, well, we can see all the stats here: deepest discharge, last discharge, average, the medium discharge. And also what I found incredible here is the total charge cycles, 7. We have put 7 cycles on this battery in 5 months. Isn't that insane? I mean, I am connected with the garage for quite a while now, and I'm charging the car. If the battery is full, all the energy of the battery goes into the vehicle. And I'm using the garden shredder and the electric chainsaw, and I haven't used the welder yet, but all my tools here, and I'm doing the battery testing with this device here. And we have used only 7 cycles so far in 5 months. Are we really talking still about compression and not compression? I mean, this is insane. This would mean we've got like 15 charge cycles a year. 15 a year, and the battery will last about 3,000 cycles until it reaches 80%, and maybe 4,000 cycles if you compress. I mean, I'm not alive anymore until this battery hits 80%. This is only my usage of the battery here in the off-grid garage, but I mean, if you have a house connected or something, you have a higher depth of discharge, of course, but 7 is insane, right? This is nothing. I just thought I mentioned this before we turn off the BMS and lose all the information. 7. I just got an idea. I'm not sure if this is good or bad. I really want to get this done right now. But I need power for the light here, otherwise I can't see anything. So what I think we could do potentially is, well, we should really cover the terminals first. Can we not bypass the BMS from there, from the battery negative to there? If I make a cable, I probably have to undo all the balance leads, so turn off the BMS so it doesn't freak out. But I could potentially get under there here and connect one cable to the battery negative and connect the other side to the smart shunt here, because we don't touch this cable, we just want to undo these screws here. And then the whole battery should still be alive, and the inverter will be alive, and the light will be here, and we all will be happy, right? It's good thinking. Okay, let's do it. Let's do it. Come on. So I've got the appropriate cable already here. Crocodile for the win. Okay, let's do it. Let's do it. Let's unplug the balance leads. Yeah, bye-bye. Bye-bye, old broken QUCC BMS. I'll sneak underneath here and connect this one to the overall negative. Nothing happens. It's good. So all our power should now go through this cable here. I will turn off the pump because it kicks in from time to time, and this is a 1000 watt load, and I don't want to have like 40 amps going through this 1.5 millimeter cable. Okay, and here we can see the, oh, here we can see the old one at the bottom and the new one here in my hand, and they look exactly the same. Same shunt, same everything, same electronics. That is all good. Just the relay has changed, so we need to change our cabling here a little bit, but this is all flexible cable anyway, so shouldn't be a problem at all. Just need to undo this one and this terminal, and then the BMS is free again. Okay, here comes the big moment. I'm disconnecting the battery minus now. Let's see if the power stays on. And the inverter keeps running through this fuse wire here. Let's see. Are we off? Yes, it works. Here, kids, don't do this at home. All right, it is all good. And the other one here. All right, here's the big moment. Running the battery without BMS. It works, guys. Okay, so let's put the new one in. It's a bit shorter, isn't it? No, not really. Okay, now we have to bend this one all the way up. Yeah, I know people have suggested to shorten this cable. I could potentially shorten it, but I never know if I keep this BMS in the future, so I want to keep the cables as long as possible. And this doesn't make a big difference at all. This is fairly big 4-gauge wire here, so it doesn't really make a big difference. All right, let's get everything back connected. All right, that was very successful. Reused the old cables, connected to the battery minus and to the charger and inverter minus here. And now we have to reconnect everything. But before I connect the balance leads now, I have to take off this one. Then the whole show will stop here because the relay is not active and the contact is not closed. So we won't have power anymore, we lose power altogether. A second one, which I will connect from here to here. I just bypassed the relay now with another cable, right? So when I take this one off, the current should go through here, through the shunt, up this bus bar, through our cable, and back to our smart shunt into the inverter, right? Okay, let's do it. Oh, it works. Okay, let's pull this one out. And now we can reconnect the balance cables, and the BMS should turn on, the relay should close, and then we can take off our crocodile cables here. I just want to see how much power actually goes through this cable here now at the moment. Yeah, 2.3 amps. Totally fine. It's a 1.5 millimeter cable. Okay, I have confirmed this with them 3 times in written, that the existing balance cables can be reused without recabling anything in the battery. I'm still nervous. Okay, first one is in. Doesn't do anything. Okay, I'll take the cable off. I could hear the relay turning on, and we are online. We've got a blue light there flashing. That's probably good. You always do the sniffing test, right? If something smells burnt, you turn it better off again. But now it's all good. Okay, let's go into our app. The QUCC connecting. Let's see if there's any different at all. Ah, okay, yes, it needs all the parameters now. Nominal capacity, cycle capacity, 280. Confirm. All right. Obviously, it doesn't have any details in there at the moment at all, because it doesn't know how far the battery is charged. It needs to be fully charged. It basically recalibrates. Once you charge the battery and discharge it a couple of times, it calibrates itself, and it's fairly precise. Actually, it's a good system. Now we've got the charging and discharging switch. When I press the charge, when I turn the charging switch off, what will happen then? It now beeps and it turned back on. Okay, let's turn the discharge switch off. Okay, that was... Okay, that obviously works. Let me here... Okay, before we turn this back on, we need to pre-charge our... No, it shouldn't make a difference, because it has a pre-charge resistor. Well, there should be power going through this resistor here to pre-charge the capacitors of our inverter, right? I don't need to do this manually. Now it's pre-charging. There we go. Okay, I'm just putting this little cover on top of the electronic again. Wish me luck. It's a live system. Okay, so all right, we have now successfully replaced the old BMS with a new BMS, which is definitely the same BMS actually. I really like this double loop situation here. I guess this makes all the difference. Okay, anyway. Oh, the temperature sensor. Should probably leave it here. So, like this. I don't know. This is probably something for colder countries. Not so much for here. Well, far more important than everything else is, how do the contacts look like inside this relay? Yeah, there's positive, negative going to the coil. And then we've got the actual contactor situation down here. Hang on, here we go. Here we go. Okay. No. Ah, there are some magnets here. This is the magnetic part. Yeah, this is a magnet, and here's another one. Okay, so for security reasons, we just disconnect the actual electronic. Now we have to well, and here's our contact, and it's not melted together. There are no burn marks on the contacts here, and this is just a little switch. See, there are no burn marks, pure copper, and nothing here on the actual switch contact. So this is the one which gets, yeah, there's the spring mechanism. And this one is the actual pin coming out. So we should probably apply some voltage here. Let's do it. Negative, positive, negative, positive. Ah, it still works. Look at this. I don't know. I don't know why it didn't work. The contacts were always closed. The only thing I can think of is that that this metal rod here was disconnected from the actual actuator here inside the coil. That is clearly working. And I don't know if I have cut this off now with my hacksaw, but that's the only explanation. And this one was pushed down onto the contacts with a spring mechanism, and that's why the contacts were always closed. And we could hear the contactor actually switching. So we could hear this from the outside, but the actual contact didn't open anymore. It was always closed. And we thought it is burned together, it is melted together because of the high inrush from the inverter. But this does not seem to be the case. There's not like burn marks or something, or it's welded together here or so. This all looks very nice and shiny. All right. Well, leave your comments down below. What do you think? Anyway, I think we just need a new relay, and then we can reactivate the whole BMS here and can reuse it. So I just need a beefy 12 or 24 volt relay with about 300 amps of switching power. And then we've got another very good BMS here for our... You didn't hear anything. Okay guys, I think so far this experiment for today. Well, the new BMS is in the battery box. It seems to work. The relay is switching, the inverter off, which is good. Prevents the battery from overcharging. I remember now. I still cannot quite figure out why there is a charge and a discharge switch in this app. But it may that this app is being used for other BMSs as well, which don't have a relay, which use the normal MOSFET transistors. And then you can control charging and discharging current individually. So this might be the case. I don't know. What do you think? Okay guys, as always, thank you so much for watching. Thanks for all your support here on the channel. Stay charged and safe, and we shall see us again in one of the next videos coming out very soon. I've got some interesting stuff happening here in the Off-Grid Garage. Stay tuned, stay charged, stay safe. It's something new. Okay guys, see you then. Bye bye. All this mess here, all this rubber stuff.